Thank you for watching Inspire Math videos. Today we're going to study how to find the greatest common factor and the least common multiple of three whole numbers by simultaneous factoring. Some textbooks recommend you use a factor tree. Factor trees are alright if there are only a few factors, but short division is very systematic and easy to organize. So let's use short division instead. If you're unsure about short division, please refer to the video whole number 3. Let's briefly review the prime factoring method, since it is very useful and we can utilize it in many occasions. For example, finding GCF and LCM of 12, 42, and 63. We need to factor 12, 42, and 63. We can do prime factoring by short division. Try not to use factor trees. We will skip the process of prime factoring, so if you're unsure about prime factoring by short division, please refer to the video whole number 5. Please also refer to the videos whole number 8 and 9 for finding GCF and LCM by prime factoring. 12 can be expressed as 2 times 2 times 3. Let's express this in ascending order with exponents, and it will be 2 squared times 3. 42 can be expressed as 2 times 3 times 7, which is already in ascending order with exponents. 63 can be expressed as 3 times 3 times 7. We can express this in ascending order with exponents, which is 3 squared times 7. Now let's find the GCF and LCM. For prime number 2, 12 has 2 squared, and 42 has 2. 2 has no exponent, but we can place 1 in the exponent. But there is no 2's in 63, so 2 is not for GCF. We choose the largest exponent for LCM, so 2 squared is for LCM. We now move to prime number 3. Both 12 and 42 have 3, and we can place 1 in the exponent. And 63 has 3 squared. We choose the smaller exponent, which is 1, for GCF. So 3 to the power of 1 is for GCF. And we choose the largest exponent, which is 2, for LCM. So 3 squared is for LCM. For prime number 7, 12 does not have 7, so 7 is not for GCF. But 7 is for LCM. Therefore, the GCF is 3 to the power of 1, which is 3, and the LCM is 2 squared times 3 squared times 7, which is 252. Now let's look at the same questions using simultaneous factoring, which is very simple and straightforward. Place 12, 42, and 63 side by side. All three numbers can be divided by 3. 12 divided by 3 is 4. 42 divided by 3 is 14, and 63 divided by 3 is 21. We have 4, 14, and 21, but there is no more common factor for all three numbers, so GCF is just 3. In order to find the LCM of three whole numbers, we continue to find a common factor for two whole numbers among 3. If you take a look at 4 and 14, there is a common factor too, so we can divide them by 2. 4 divided by 2 is 2, and 14 divided by 2 is 7. Nothing changed for 21. Now we have 2, 7, and 21. If you take a look at 7 and 21, there's a common factor 7, so we can divide them by 7. Nothing changes for 2. 7 divided by 7 is 1, and 21 divided by 7 is 3. We now have 2, 1, and 3. Since there is no common factor for any two whole numbers, we stop factoring. In order to find the LCM, we need to multiply numbers in the shape of an L, which is 3 times 2 times 7 times 2 times 1 times 3. 3 times 2 times 7 is 42, and 2 times 1 times 3 is 6. So LCM is 42 times 6, which is 252. Let's try another question. GCF and LCM of 72, 84, and 180 by simultaneous factoring. Place 72, 84, and 180 side by side. All three numbers can be divided by 2. 72 divided by 2 is 36. 84 divided by 2 is 42. And 180 divided by 2 is 90. We have 36, 42, and 90. They all can be divided by 3. 36 divided by 3 is 12. 42 divided by 3 is 14. And 90 divided by 3 is 30. We have 12, 14, and 30. They all can be divided by 2 again. 12 divided by 2 is 6. 14 divided by 2 is 7. And 30 divided by 2 is 15. We now have 6, 7, and 15, but there is no more common factor for all three. So GCF is 2 times 3 times 2, which is 12. In order to find the LCM of three whole numbers, we continue to find a common factor for two whole numbers among three. If you take a look at 6 and 15, there's a common factor 3. So we can divide them by 3. 6 divided by 3 is 2. Nothing changes for 7, and 15 divided by 3 is 5. Now we have 2, 7, and 5. Since there is no common factor for any two whole numbers, we stop factoring. To find the LCM, we need to multiply the numbers in the L shape, which is 2 times 3 times 2 times 3 times 2 times 7 times 5. 2 times 3 times 2 is 12. 3 times 7 is 21, and 2 times 5 is 10. So LCM is 12 times 21 times 10, which is 2,520. Let's try one more question. GCF and LCM of 60, 90, and 126 by simultaneous factoring. Place 60, 90, and 126 side by side. All three numbers can be divided by 2. 60 divided by 2 is 30. 90 divided by 2 is 45. And 126 divided by 2 is 63. We have 30, 45, and 63. They all can be divided by 3. 30 divided by 3 is 10. 45 divided by 3 is 15. And 63 divided by 3 is 21. We now have 10, 15, and 21, but there is no more common factor for all three. So GCF is 2 times 3, which is 6. In order to find the LCM of three whole numbers, we continue to find a common factor for two whole numbers among 3. If you take a look at 10 and 15, there's a common factor, 5. So we can divide them by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. And nothing changed for 21. Now we have 2, 3, and 21. If you take a look at 3 and 21, there's a common factor, 3. So we can divide them by 3. Nothing changed for 2, and 3 divided by 3 is 1. And 21 divided by 3 is 7. Now we have 2, 1, and 7. Since there is no common factor for any two whole numbers, we stop factoring. To find the LCM, we need to multiply the numbers in the L shape, which is 2 times 3 times 5 times 3 times 2 times 1 times 7. 2 times 5 is 10. 3 times 3 is 9. And 2 times 1 times 7 is 14. So LCM is 10 times 9 times 14, which is 1,260. Here are some challenge questions. Try them out. Sample solutions are linked under the video. Hope you can solve them. Thank you for watching Inspire Math videos. Please subscribe if you'd like to join our Inspire Math tutoring community. There are some related videos linked below. Thank you and have a good one.